Today, class, we're going to talk about evaluating functions. So let's review real fast what a function is. If you remember, functions are a relation that meets certain criterion. And one of the criterion is that if I'm given a list of coordinates, that the x values have to be unique. So in this particular question, it's asking what value cannot go in this place right here. Well, when you look at this, okay, you've got a 3 as an x value, you've got a 4 as an x value, and a -1 as an x value. So any other value other than 3, 4, and -1 can be placed in this spot with no problem. So the only ones that I can use are, in this list of numbers down below, I can't use the 3. It can be a 5. It can't be a 4 because the 4's here and the 3's here. It can be a 0. It can be a -2. It can be a 0.8. It can't be a -1 because this x value is -1. And it can be a 9. Okay, so that's how we determine a function if we're given a series of coordinates. Okay. Now there are a couple other ways, like on the assignment that we did the other day. This one right here. Okay, so if I were given a t-chart, we could determine if it's a function by looking at the x values. If all the x values are unique, then it's a function. And this one right here, this t-chart right here, all the x values are 3, so this is not a function. And the next one, all these values are unique, so this is a function. It is perfectly fine if all the y values are the same. It's the x values that we're looking for. And in this last one, also it can be a function. Now when we're dealing with a graph, what we're looking for is a vertical line test. Okay, so if you'll look at this y-axis right here, it actually hits this graph in 3 different points. Hits it right here, here, and here. So this is not a function. In order for it to be a function, for every vertical line you draw, it can only hit the graph in 1 point. So in this one, is this one a function? Yes, this is a function because I can draw a vertical line here, 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 I missed that one, and here, and only hit 1 point. So this is a function. This graph right here, again, each line I draw will only hit 1 of those points, so it is a function. The next one, if I draw a line right here, again, it hits it in 2 points, so this is not a function. Now we also looked at mappings. Okay, these were 2 mappings. Okay, so this one, these numbers right here are the x values in a coordinate system. Okay, whenever I do a listing, like these 2 right here, in this mapping, this right here is just all the x values, or it's called the domain. Okay, the other ones in the other circle are the y values, or it's called the range. Okay, so in a mapping, again, all of these x values must be unique. Okay, and they can only have 1 output. So in this one right here, if we were to list this in coordinates, this would be -2, 1, 1, 2, 5, -4, and -3, -2. And those would be the coordinates from this mapping. So this is a function. This other one here, this is not a function. Because you'll notice this 5 has 2 outputs. So the coordinates that it would be, that we would use for this one is 5, 4, 5, 1. So you'll notice the 5 is used twice. So that's a sign that it is not a function. And then -3, -4, -3, -2. Again, the -3 is used twice. So this is not a function either. Right? So those are the ways that we determined whether or not a graph, a t-chart, a mapping, or a list of coordinates is a function. So today what I want to look at is how do I evaluate functions? Okay, or what is function notation? So if you look at this slide right here, you'll notice that there are 2 ways of writing things. It says functions can be written in 2 formats. They can be written as y equals, which is what we're very commonly used to, because we're used to y is equal to mx plus b. Right? We're used to that. Sorry about that line going through there. Okay. But it can also be written with this little format right here. And this is what we call our function notation. And it stands for the function of x, and the way you say it is f of x. So this says f of x is equal to 3x plus 5. Right? g of x is equal to 2x squared plus 1. H of x is equal to x divided by 3. J of x is equal to 2x. Right? So these are ways that we write functions using this function notation. And the reason why we do that is to differentiate the function from one equation to another. So this is an f of x function. This is a g of x function. They're the same thing. But you'll notice that this f of x and this y, they're in the same place. So it's just a substitution. They mean the same thing. So now if I want to evaluate a function basically means, okay, so this is f of x is equal to 2x plus 5. And I want to evaluate that for f of 6. Well, if you'll notice whenever I put this underneath here, that this 6 is in the same place as the x. And that means that all throughout the expression, I just substitute the 6 in wherever x is. So evaluating a function is nothing but taking whatever value is here and plugging it into the x in our equation. So this would be 2 times 6 plus 5. And then we evaluate just like we did with expressions. So 2 times 6 is 12 plus 5 gives us 17. If we have f of 21, well, that just means I'm going to take the 21 and plug it into the x. So in this one, it's 2 times 21 plus 5. So that gives us 2 times 21 is 42, plus 5 gives us 47. And if we use the negative 3, it's the same exact thing. 2 times negative 3 plus 5. Well, 2 times negative 3 gives us negative 6, plus 5 gives us negative 1. Okay? So to evaluate a function, all we're doing is taking whatever number we have in this parenthesis and substituting it in for x. Now we can apply this as well. So if we were to look at a couple of questions here, it says 2 dog groomers use the following equations to calculate the total cost, y, depending upon the number of hours spent with each dog. Okay, x. So this is an equation on how barking lot grooming calculates its total cost. Okay. This one is for tidy paws. But you'll notice that this one is a y equals and this one's a y equals. So it's really hard to differentiate the two. Okay. So I can use function notation to help differentiate them. To help keep track of which function goes with each groomers, we can write the functions using function notation. And we can use whatever letter we want to for the function. So for barking lot grooming, we're going to use b of x. So we would use that formula. For tidy paws, we'd use p of x to determine the cost. Okay. So we could actually evaluate some using those particular notations. So in this one right here, it says b of 3.5. Well, because of the b is here, that means I'm going to use the barking lot grooming equation. So we would just have 5 times 3.5 plus 3. And this one, it might be even easier sometimes because we are allowed to use calculators to pull out the calculator. So let's see if we can do that. So here is our calculator. So this one, in order to evaluate it, we're going to do 5 times 3.5. So 5 times 3.5 and then plus 3. And we get a value of 20.5. So the cost of 3.5 hours would actually be $20.50. If we did that with tidy paws, we would do the same thing. We'd plug the 2 in. So 3 times 2 plus 21. Well, this one I wouldn't need a calculator for. So 3 times 2 is 6 plus 21 gives us 27. And again, because we're talking about total cost, it is $27. Okay, now, what if I gave you a problem like this? It says, well, what if a customer at Barking Lot Grooming paid $19.25 to have their dog groomed? How many hours did it take the groomer to groom the dog? Well, in this one, you'll notice that we've got the same formula. B of x is equal to 5x plus 3, but it says B of x is equal to $19.25. Well, we can substitute just like we did in these previous problems where it gave me this value for x. I can actually plug this 1925 in for b of x because it says that's what it's equal to. So I can take the b of x and substitute in the 1925. So 1925 equals 5x plus 3. And in this particular problem, my job is to find out what x is. Well, in order to do that, we've got to remember a little bit about solving equations. Well, the first thing I'd get rid of is the plus 3 by doing a plus negative 3. And if I do it on one side, I have to do it on the other side as well. So we do 1925, take away 3, which gives us 1625. And that's equal to 5x. Now to get rid of the 5, the multiply by 5, we do a divide by 5. So we do a divide by 5. So x is equal to, this is one I'd like to pull my calculator back out for. So we get 16.25 divided by 5. We find out that our value is 3.25. So we look back up at the question to find out what our label is, and it says how many hours did it take the groomer to groom the dog? So this 3.25 is hours. So we can evaluate functions exactly the way we evaluated expressions. Okay, so now we're going to work on a little assignment that looks like this right here. So you'll notice that in the problems I have f of 12, h of negative 5, h of 15, g of 12, c of 2. And you'll notice at the top of the page we've got functions that start with that particular letter. So all the f of 12s and f of 3 and okay, all the f's are going to go with this function. All the h's will go with this function, the c's with this function, and the g's with this function. And I'd like for you to evaluate each of these functions for the given values. Until next time.